Hey guys, welcome to the next video. Dr. Zahir Math will be dealing with more advanced topic today, eigenvalues and eigenvectors of a 3 by 3 matrix where the eigenvalues are complex. Complex values means what? I. The same idea I have done for 2 by 2 matrix and I uploaded as a video. So if you didn't watch that video, please go back and watch that video, then come back to this one, right? If you already worked with real eigenvalues, this will build on that same knowledge. Let's break it down carefully step by step. Okay, right. Complex eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors for the matrix A is equal to 2, minus 1, 0, 5, 2, 4, 0, 1, 2. Right. So it's a 3 by 3 matrix. It's a 3 by 3 matrix. Okay, right. So let's start this one. First thing is step number 1. In step 1, we are going to find the characteristic equation lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. What is beta 1? Beta 1 is equal to sum of leading diagonal elements. Sum of what? Leading diagonal elements. Right. What are your leading diagonal elements? This is the leading diagonal elements. Okay. So beta 1 is equal to 2 plus 2 plus 2, which is going to become what? 6. So beta 1 is equal to 6. Let's go with beta 2. What is beta 2? Sum of minors of leading diagonal elements. Sum of minors of leading diagonal elements. Okay, right. So what is the minor? We are going to say for this one, let me write here. So let me write the matrix and then erase it. 2, minus 1, 0, 5, 2, 4, 0, 1, 2. So we are going to take the minor of this one. So it means this row you shouldn't take, this column you shouldn't take. 2, 4, 1, 2. So this is 2, 4, 1, 2. Plus we are going to take the next minor of the leading diagonal, right? So what is the next minor? Let me erase this one and I'll write another one. So we are going to get now 2, minus 1, 0, 5, 2, 4, 0, 1, 2, right? We are going to take the minor of this element. So this row you shouldn't take and this column you shouldn't take. 2, 0, 0, 2, right? So 2, 0, 0, 2, right? Next, let me erase this one. I'm going to find the minor of this element. So 2, minus 1, 0, 5, 2, 4 and 0, 1, 2. This row should not take, this column should not take. So you'll get what? 2, minus 1, 5, 2, right? Let me calculate the values of this one. This is equal to 2 times 2 is 4 and minus 4, okay, right? And then plus 2 times 2, 4, minus 0, plus 2 times 2 and then minus of minus, it's going to become plus 5. So this is equal to 0 plus 4 plus 9. So which is equal to 13, right? So beta 2 is equal to 13, right? So let me write here beta 2 is equal to 13. Okay. Let's go for beta 3. Beta 3 is equal to determinant of A, right? So let me go to the calculator, determinant. So restart your calculator, shift 9, 3 equals, press step number 1, mode, okay, 6, mode 6, and then 1, 1, AC, 1, 1, AC. Now we are going to do the next step, mode 6, mode, right, and then 6, then you are going with 1, right? Then we are going with number 1 again, which is a 3 by 3 matrix, okay, number 1. And you're going to give the input, which is going to give the inputs, right? Okay. So give the inputs 2, minus 1, and then 0, then 5, then 2, then 4, 0, 1, and then 2. Then press AC. After finish this AC, then you go for shift 4, right? Shift 4. Then you're going to get the det. So det is this number 7. So please press number 7, okay, and then det off. After that you press again shift 4, again shift 4, right, and your data is in number 3, so press number 3. So then close the brackets, okay, right. So now your screen will looks like det of mat A. The screen will looks like this. This is the command we are going to give in the calculator. Det of mat A and then press equal sign. You're going to get the answer 10, okay, right. So determinant of A is equal to 10. So beta 3 is equal to 10. So we got beta 1, we got beta 2 and we got beta 3. Now we are going to write the characteristic equation lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 is equal to 0. So lambda cube minus, what's your beta 1? Beta 1 is 6 lambda square. I think 6 I remember. Right. And then 6. Okay. Right. 6 and then 13. Right. 6 and then 13 lambda. Right. And then minus beta 3 is going to become 10 equal to 0. Right. Now after that, please go to mode 5, right? And then number 4, I think so. Let me start. So now again, you restart your calculator, mode and then 5, okay, 5. And then you're going to number 4. When you give the number 4, go by order, which is plus 1, then give minus 6, okay. Then you give 13. If anything is missing, give 0, but usually we write with 0, 13 and then minus 10, okay. Go by order always, okay. So if you press all these things, you will get lambda 1 is equal to, that is x1, which is 2. And then you will get 2 plus I. Wow. And next, definitely 2 minus I, because what is the meaning of that? Complex roots always occurs in pairs. It will come as a pair only. Okay, right. Yes, so 2 plus I and 2 minus I is your root, right? So this is a real root, okay, and this is a complex root, okay. So that's why this topic comes under what? Complex eigenvalues and eigenvectors. So therefore your eigenvalues are, what are the values you got it? You got 2 and 2 plus I and 2 minus I, right? So eigenvalues is over. Now we are going for what? Eigenvectors, right? So for eigenvectors, what is the formula to find the eigenvectors? Formula to find the eigenvector is matrix my A minus lambda I times x is equal to 0. Right? So we are going to calculate A minus lambda I. That means I told you the changes will occur only in what? In the diagonal elements. So it means here you will get minus lambda, here you will get minus lambda, here you will get minus lambda, right? So let me remember the diagonal numbers is 2, 2, 2. So it means you're going to get the elements as 2 minus lambda and then here 2 minus lambda and then here 2 minus lambda. This will be same element minus 1, 0. This is same 5 and this is 4. And this is 0 and this is 1, right? So this operating on x1, x2 and x3 is equal to what? 0, 0, 0. I told you this is a column vector. x1, x2, x3 is a column vector. So this one going to become what? Equation number 1. So in this only we are going to put what? Lambda is equal to first value, second value and third value, right? Let me put first case 1, right? So case 1, okay. So I'm going to put case 1, right? I'll write separately, no problem. Last time I wrote congested. So now I put lambda is equal to what? 4, right? The first value. 4 or 2. Sorry, it's 4, 2, I think, right? Yes, lambda is equal to 2. So if I put lambda is equal to 2, 2 minus 2, 2 minus 2, 2 minus 2. So it will be 0, 0, 0. So it will be 0, 0, 0. Remaining elements say minus 1, 0. Minus 1, 0, then here it is 5, here it is 4, then it is 0 and 1, right? Operating on x1, x2, x3. So we are going to get 0, 0, 0. So what I did, I put lambda is equal to 2 in equation number 1, okay? Right. So the equations are what? 0 x1 minus x2 plus 0 x3 is equal to 0. And then 5 x1 plus 0 x2 plus 4 x3 is equal to what? 0. Again, I'll remember, you can take any two equations, either first and second or second and third and 1, provided you should get non-zero eigenvector. If you are getting 1 and 2 equations, if you are getting 0 vector, please interchange your choice as second and third equation. Suppose your second and third equations give 0 vector, again interchange your choice with third and first equation, because eigenvector is a non-zero vector. Keep in your mind. So we are going to use what? Cross multiplication method, right? So we are going to use cross multiplication method. So what is cross multiplication method? Start from the middle, minus 1 and then 0, 0, minus 1. So minus 1, 0 and then 0, minus 1, right? And then it is 0, then 4, 5, 0, right? So in this cross multiplication method, we have taken the numbers, right? Now we will start x1 divided by, x2 divided by and x3 divided by, okay? right? So we are going to multiply this one and this one, right? So it's going to be minus 4 minus 0. Actually, it is minus 0, right? 0 times 5 is 0 and 4 times 0 is going to become what? 0. Yes. The next one, which is going to become 0 times 0, and it is going to be plus 5, right? So it will be x1 divided by minus 4, which is equal to x2 divided by 0 and x3 divided by 5. Teacher, there is a 0. You said it's a non-zero vector is an eigenvector. Again, I'm telling non-zero, zero vector means all the three are 0. This is called zero vector. Okay, right. Keeping 1 as 0, 2 as 0, no problem, right? So therefore, your first eigenvector is equal to minus 4, 0 and 5. So this is going to become what? The first eigenvector, right? Let's go to the second eigenvector, which is for the complex values, right? Okay. So let me write the equation again, no problem. Equation 1, I will write again. So equation 1 implies, okay, right, which is 2 minus lambda, then minus 1, 0, then 5, 2 minus lambda, 4, and 0, 1, and then 2 minus lambda, right? Easy to remember. x1, x2, x3, which is equal to what? 0, 0, 0, right? Let me check whether once again, because a little bit after finishing the video, it may be wrong. So it is 2 minus lambda minus 1, 0, 5, 0, 1, 4, 5, 0, 1, 4, 5, 4, 0, 1, 5, 4, 0, 1. Yes, correct. So x3 is equal to 0. So let us start case 2. So this is your case 2. In the case 2, we are going to put, right, actually this is your equation 1, okay? Put lambda is equal to 2 plus I. That is the next complex root, right? Yes, in equation 1, very carefully do complex values, you will make mistakes. Slowly do, nothing wrong in this. 2 minus 2 plus I, minus 1, 0. 5, 2 minus 2 plus I, and then 4, then 0, 1, then 2 minus 2 plus I. Close it, and then x1, x2, x3 is equal to what? 0, 0, 0, right? Now slowly you simplify this one. Let me simplify the side. 2 minus 2 plus I. So which is equal to minus 2, right? And then this is going to become what? Minus I. This is 2. 2 gets cancelled. So you are going to get the first one as what? Which is going to become minus I. Okay. Then this will be the next one, the next middle one. 2 minus 2 plus I. So 2, this goes as inside minus 2. And this goes as inside, this is minus I. So this is also going to become minus I, right? Let's start the next one. 2, all are same, but still I'm working out. 2 minus 2 minus I. So 2 gets cancelled. So you're going to get minus I. So what are the remaining values you have? Minus 1, which is 0, and minus 5. And this is 4 and 0, and this is 1, which is operating on x1, x2, x3 is equal to 0, 0, 0. Most of you says the videos are so lengthy, that's why I'm talking a little bit faster. Okay, please bear with me, right? So let's start to write the equations. Okay, right? Yes, the first equation will be minus I, first row, first column, second row, first column, third row, first column. Okay, minus I x1, minus 1 x2, and then plus 0 x3 is equal to 0. Then minus 5 x1 minus I x2, and then plus 4 x3 is equal to 0. Let me check I am getting 0 vector or not. If I get 0 vector, I'll change my options. Okay, right. So let's start the method of cross multiplication. Start from the middle, end with the middle. So minus 1, 0, minus I, minus 1. Minus I, 4, minus 5, minus I. Okay. Right, again I'll repeat. Minus 1, 0, minus I, minus 1. Minus I, 4, minus 5, minus 5 or plus 5? So I think plus 5, sorry. This is plus 5. Okay, right. Plus 5, it is not minus 5, it is plus 5. Sorry, it is plus 5, it is plus 5. Again I'll repeat. Minus I, plus 4, plus I, plus 5, and then minus I. Okay, right. So it is plus 5, right? Yes, there is no change there. Plus 5 only, right? Let me start the values. x1 divided by, right, and x2 divided by, and x3 divided by, right. x1 divided by minus into 1, 4 is minus 4, and this is going to become plus 0. And 0 into 5, it's going to become 0, and this is going to become plus 4i, right. And minus I into minus I, you know very well. If you don't know, you just use the calculator under complex mode. Please use the calculator under complex mode. How you get complex mode? Shift mode, you will get complex. Keep in your mind. Or you should remember, I times I is I square is minus 1. most of the places in engineering we are using, right? So I times I is I square minus 1. Already here is minus minus going to become what? Plus 1. So it is minus 1. Again I'll repeat. Let me repeat again. Minus I times minus I. Okay. Minus into minus plus. I into I is what? I square. I square is what? Minus 1. Keep in your mind. So minus 1. 5 times minus 1, which is going to become what? Plus 5. Okay, right. So x1 divided by minus 4. X1 is not looking nice. X1 divided by minus 4 equals x2 divided by 4i and x3 divided by 4. Okay. Is there a common table here to cancel? Yes. What is the common table? Come on, tell me. Dr. Zahir, common table is what? Which is 1 and which is 1 and which is 1. Which is a 4 is a common table here. Why? 4 ones are 4. This is a common table, right? So finally we are getting x1 divided by minus 1, which is equal to x2 divided by plus 1 and x3 divided by plus 1. So what is your, sorry, this is not plus 1, this is I. So what is your vector? Sorry, this is I because there is a I here, right? So what is your second vector? Capital X2 equals minus 1 I and then minus 1. Right? Is it clear now? This is the second eigenvector, right? Let me go for case 3. So case 3, I'm going to put lambda is equal to, let me write the equations again, right? So the equations are what? The equations are 2 minus lambda, minus 1, 0, and 5, 2 minus lambda, 2 minus lambda, I think here 4, 0, 1, right? So this times x1, x2, x3 times what? 0, 0, 0, right? Okay. So now what we are going to do? We are going to put lambda is equal to, what is the value? 2 minus I in equation 1. Which is equation 1? This is equation 1, right? Slowly put it without making any mistakes. Let me start here. 2 minus I, 2 minus 2 minus I, 2 minus 2 minus I. Here luckily you got same element, but not every time same. Keep in your mind. Minus 1, 0, right? So this is going to become minus 1 and then 0, then minus 5 and then this is 4, this is 0 and this is 1. Operating on x1, x2, x3 is equal to what? 0, 0, 0. Okay, yeah, right. 0, 0, 0. My matrix is not perfect. So let me make it as perfect. 0, 0, 0. Right. So let us simplify this. Okay, 2 minus 2i. So it is going to become what? 2 minus 2 goes inside minus 2 and minus of minus is going to become plus I. So 2 gets cancelled. So you're going to get what? I. Okay, right. So let me start the matrix. Okay, right. So we are going to get here I. So the column elements are I. Okay, now these elements are minus 1, 0, right? Minus 1, 0, right? And then here it is 5, it is 4, I think 0, 1, 5, 4, 0, 1. Okay. Operating on x1, x2, x3 equals 0, 0, 0, right? So we are going to write the equations now. First row, first column, and second row, first column, right? And the third row, first column. This is the idea. So let me start here, right? So this is going to become ix1, right? Minus 1x2 plus 0x3 is equal to 0. 5x1 plus ix2 plus 4x3 is equal to 0, right? So again I'll repeat, ix1 minus x2, 0x3. 5x1 plus ix2 plus 4x3 is equal to 0. Now method of cross multiplication, start from the middle. Minus 1, right? Start from the middle. Minus 1, right? And then 0, I, then minus 1, I, 4, 5, and then plus I. Okay, right. Again I'll tell minus 1, 0, I, minus 1. And then I, 4, 5, I. Okay. So x1 divided by x2 divided by x3 divided by. Okay. Right. So now we are going to do this one. So what we are going to do? Minus 4 and then minus 0. And next is 0 and then minus 4i. Okay. Right. And then this is I into I. Just now I told you I into I is I square. I square is minus 1. So it is minus 1, and 5 into minus 1 is going to become plus 5. Okay. If you don't know this one, don't worry. Go to calculator. Use first step, shift mode. Shift mode. Again I'm writing shift mode, right? And then you press complex, CMPLX, complex, I think number 2. Okay. Then after that you press I. That I is near what? E and G. Where is I? If you want to press I in the calculator, there is a E and G. So if you press E and G, you will get I. Okay. So x1 divided by minus 4, x2 divided by minus 4i, and x3 divided by 4, right? So what happens now? It is going to get cancels, right? Okay, so it gets cancelled. 4 is a common table, 4 is a common table, 4 is a common table. So you'll get minus 1 and you will get minus I, and you will get here plus 1. So what will be your next eigenvector, which is x3? It's going to become minus 1 and then minus I and then plus 1 is going to be your next eigenvector. So we are going to present the answer in a neat manner. So eigenvalues lambda is equal to, what are the eigenvalues? We got it. Lambda is equal to, what are the values? We got one eigenvalue, I know, 2 plus I, 2 minus I. And then another eigenvalue is what? Lambda is equal to 2, right? So eigenvectors, just now I got x3, minus 1 minus I 1, minus 1 minus I 1. Okay, this is your x3, right? Let me write here 2 plus I, and here write 2 minus I. Okay, so eigenvector x3 is equal to minus 1 minus I 1, right? Then let me, what is the second eigenvector? I think second eigenvector is 1. Second eigenvector is minus 1 I plus minus 1. Here is, it's not minus I, it is plus 1, right? See, look here, it is plus minus 1 I 1. So which is minus 1 x2 is equal to minus 1 I 1. Luckily I saw that, I corrected the mistake, right? Then I will go for x1, which is lambda is equal to 2. I got the first eigenvector as x1, which is going to get, this is your x2, and I'll get x1 minus 405. Is it correct? Minus 405, yes. Minus 405. So it is minus 405. Minus 405. This is your next eigenvector. Okay, minus 405. So in this way you are going to get your complex eigenvalues and eigenvectors. Okay, right? So let me have a box of this. You're going to present your answer very neatly. Keep in your mind. Okay, right? So this is the way you're going to keep, and this is your lambda. Okay, right? So in this way we are going to finish this complex eigenvalues and eigenvectors, right? Okay, so what we are going to do it, we are going to finish it, right? We have done it. We have tackled complex eigenvalues for a 3 by 3 matrix, right? Great work. Make sure you practice these problems to get comfortable with the process. In the next video, we will dive deeper into more advanced concepts in eigenvalues and eigenvectors. That is going to be the next interesting topic, diagonalization. Don't forget to like, share and subscribe to keep getting more educational content. See you soon. Take care. Bye-bye.